Hello and welcome. This video will demonstrate the capabilities of AJA and Colorfront's latest addition to their product lineup, the Analyzer. The Analyzer is, as its name suggests, a tool for analyzing image content. If you already know Transcoder, you'll find the Analyzer familiar. In fact, it shares Transcoder's code base, but its feature set has been extended to cater for the needs in image analysis, and as opposed to Transcoder, it works on a live video signal instead of file-based sequences or clips. The Analyzer is targeted at colorists, cinematographers, creative professionals, and QC labs, everyone in need of analyzing content in the age of HDR television and digital cinema. It could be placed in a broadcast track to analyze live camera signals, or in a studio environment to quality check deliverables and media. It could also be used on set to help the cinematographer, on-set colorist, or DIT to accurately analyze content, be that either in standard or high dynamic range in resolutions ranging from small HD to 4K. The user interface can be toggled between a single view mode and the combined view mode, all of which can be accessed in the Analyzer menu's Analyzer Mode menu item, or by pressing through the F1 to F9 keyboard shortcuts. Press F1 through F4 for single instrument views and F5 through F9 for multi-instrument views. View the content by clicking on Image or by pressing the F1 shortcut. Timecode carried by the SDI signal can be superimposed over the image by enabling timecode on image or by pressing Ctrl-T. The Waveform menu item or the F2 shortcut activates the waveform monitor. Several data analysis modes including waveform and histogram displays can be selected from the Analyzer menu Analyzer Mode item or by using the Ctrl F1 through F9 shortcuts. Should you need to zoom into the waveform, you can do so by clicking Zoom, Waveform Zoom, or hitting Ctrl and W. Waveform graticule can be switched between SDI code values, percentage or nit levels, which is the default setting. Analyzer is designed to detect the incoming signal format automatically, provided that Auto Detect is enabled in the Video Resolution menu item. However, there can be use cases when this is not possible. If the incoming signal is not properly detected, the Auto Detect Options menu item has further detection-related settings available, or you can manually choose a resolution for your incoming signal to up to 4K in video resolution. The Analyzer Color Space menu item is where you have to set the incoming signal format in case it is not properly recognized. You can choose between several HDR, HLG, and SDR settings, or if you have live incoming signal from a camera, the camera menu allows you to select camera-specific input color spaces such as Vlog, S-Log, or Log-C. The most frequent color spaces got their own shortcuts. Use Ctrl F10 if your incoming signal is Rec 709 SDR, Ctrl F11 if it's in HLG Rec 2020, and press Ctrl F12 for HDR Rec 2020. When Auto HDR mode change is enabled, Analyzer will automatically switch between several different HDR modes like HLG or HDR10 based on the available HDR metadata in the SDI signal. Analyzer can interpret both RGB and YCBCR signals. In case your incoming signal is YCBCR, you can define how it is going to be mapped to RGB values by using either the Rec 709 or the Rec 2020 standard matrices in the YCBCR matrix menu item. The False Color menu item lets you analyze the content for legal brightness and gamut values. When brightness is selected, the colors of the content will switch to a blue to red spectrum, where blue is indicating dark areas, green the mid values, and yellow the bright areas. If a pixel turns red, the signal's nit levels are getting near or above the legal limit. The Brightness Warning menu item will display the image using a monochrome grayscale spectrum. A pixel's color will turn orange where brightness is getting over 90% and turn red where it exceeds legal levels. The same color coding applies to the gamut and gamut warning options, except this time it is the gamut coverage that is being analyzed instead of luminance. Blue to yellow or black to white will indicate legal color values. Red means your pixel saturation are reaching outside the legal gamut triangle, which is specified in the input color space menu item. You can toggle through all these four modes using the Alt F1 through the Alt F4 shortcuts. Alt and F5 will switch back to normal viewing mode. F3 will activate gamut mode. In gamut mode, the two lines on the left side of the screen will display the current frame's brightness level and color gamut coverage. On the right, you can review how the image's pixel values are distributed within the CIE graph and the appropriate color gamut triangles. Should you need to display white points, you can do so in the Analyzer menu's white point item. When activated, this will place a white rectangle over the CIE graph to indicate the location of the selected white point, which can be either D65 or DCI. Analyzer mode vector scope or the F4 shortcut will toggle the vector scope display. The vector scope target menu item enables switching between full and broadcast safe modes. Use the zoom vector scope zoom menu item to zoom into the vector scope tool or press Ctrl V. This can come in handy when working with HDR signals. All these single instruments can be placed onto one screen layout in Combine View mode. In Combine View mode, the UI can be customized to toggle between audio channels, the pixel picker, vector scope, and log views. Select one of the Combine menu items in Analyzer mode to access the Combine views or toggle through the F5 to F9 shortcuts. Pressing F5 or clicking the Combine with Audio menu item will display the Combine view with the audio phase meter. You can select which audio channels you want to monitor in Audio phase meter. You can monitor channel pairs or groups of 8. Click the Level Meter menu item if you prefer to monitor audio levels instead of phase. F6 will display the Combine view with the pixel picker. Bring your mouse pointer over the content area and click the left mouse button to pick and analyze the values under the mouse cursor. Note how the picked values are pointed out on both the waveform and gamut views, and if you select a multi-channel view like the Waveform YRGB menu item, the individual primary channels will display the picked RGB and luminance components separately for each channel. The pixel picker window shows the picked area magnified, displaying values for each pixel. The values you see are directly read from the live SDI signal. Go to Analyzer Pixels view to change how the pixel data is displayed, hexadecimally, decimally, or in nit levels. The picked RGB values displayed in the waveform view will be averaged and calculated from the pixel values that fall within the white rectangle area of the picker. Both single and combine views support pixel picking. You can toggle all displays to single line mode in Analyzer mode, single line mode. In single line mode, your displays will show lines and dots instead of waveforms, and the line number will be displayed over the content screen. If you work on a lower resolution monitor, you can use the right mouse button to fine-tune your pick. The picker is also indicating the picked values on the vector scope. F7 will show the combine view with the vector scope. When QCing content, it is often needed to log gamut or brightness warnings to a file. The log window or the F8 shortcut will display brightness and gamut warnings if your signal carries values close to or exceeding maximum. You can capture these warnings into a log file by clicking the Log, Start Log to File menu item or by pressing the Ctrl-L keyboard shortcut. You can change how your events are logged into the log file, set by timestamp, by timecode, or by the combination of the two in the log window timecode menu item. Should you need to clear the log data, you can do so from the log menu item or by pressing Ctrl-D. You can apply LUTs to the live video signal pre- or post-analysis. Go to Window and point to Analyzer Scope LUT. This will apply a LUT before analysis, thus will impact your waveform signal. The Analyzer Display LUT will be effective only over your content, and it will not impact the analyzed values whatsoever. You can also manage your own LUTs in either .cube or 3D mesh formats. Go to the Setup menu's Manage LUT submenu to upload or delete lookup tables. You can manage setups from this very same menu. Settings you use most often can be saved into setups. For instance, if you QC DCPs often, you might want to save all DCP-related settings, such as P3 DCI as the color space and DCI as the white point, into a setup for easy access in the future. Similarly, if you happen to frequently analyze HDR data, you can save all related settings into a setup. All current settings can be displayed by pressing F9, which will open Combine View mode with the info window. Analyzer's instruments can be dimmed or brightened with the Analyzer Gain menu item. Increase or decrease gain from within the menu, or alternatively you can also use the Ctrl+ and Ctrl- shortcuts, reset to the defaults in the menu. Analyzer provides stills capture, load and save functionality. You have 4 memory slots to save stills to by using the Alt and numpad 1 through numpad 4 keyboard shortcuts. Recall saved stills with Ctrl numpad 1 through 4. Jump back to the live video signal by pressing Ctrl and numpad 5, or alternatively, you can do all these steps from the video menu's capture and recall menu items. Finally, you can fine-tune Analyzer settings using the Tab shortcut. You can adjust nit levels, tolerance levels, and skin tone coordinates in the QC tab, while the Network tab allows you to configure network-related settings. You can adjust safe area markers in the Safe Area tab, such as aspect ratio, safe action percentage, or line opacity. You can toggle your safe area markers using the Safe Area on Image menu item or the Ctrl-S keyboard shortcut. This is AJA and Colorfront's Analyzer in a nutshell. Enjoy!